Hello viewers on YouTube. In this video tutorial, we are going to consider inclined mirrors. So usually when an object is placed in front of a plane mirror, then an image will be observed. But when an object is placed symmetrically in front of two inclined mirrors, then usually several images are observed. So in this video tutorial, you are going to understand why and how these images are observed. So let's begin by considering two mirrors that are inclined at an angle of 90 degrees to themselves, that is, perpendicular to themselves. So this is the first mirror, and this is the second mirror. Okay? Since they are mirror, they are going to have their rough surface. Perfect. Now, if an object is placed symmetrically in front of these two mirrors, what will happen? Where and how the image are going to be formed? So let the object be somewhere around there. I'm going to call that or represent that with O. If the first mirror stretching or standing vertically is M1 and the second one is M2, M1 will form an image of O behind it, but it will be at the same distance from the mirror as that of the object. So I1, which I will represent as the image over here, formed by M1. Now M2 will also do the same thing. We also formed I2 image, same distance as the object from the mirror. Perfect. Now, I1 or M1 will now take the image formed by M2 and receive it as an object and then form another image behind the intersection point. And that will be somewhere around there. And I'm going to call that I3. Now, not only M1 is going to do something like that, M2 is going to do some same thing. So M2 is going to take the image formed by M1 in the first place, receive it as an object, and then form another image, but at the same position as I3. So they are going to overlap, and therefore we won't be able to differentiate them, and therefore we consider it to be one, which simply means all the images that will be formed by these two mirrors, M1 and M2, that are perpendicular to themselves, or that obtain an angle of 90 degrees to themselves, will simply be equal to 3. And that's it. Now you might be wondering, why is it 3? Why is it not 2? Besides, it's just two mirrors that are subtended themselves. So let's look into that as well. So suppose we want to join all these points with a circle, since they are up to 4. Okay, so we can join them with a circle. However, I just need to bear with my circles. Might not be that perfect as expected. Okay, let's just work with that just to disclose this concept. So if this is the circle, now I can clearly see that M1 and M2 has become a sector of the circle, which is subtending an angle of 90 degrees as the center of the circle. And this is the center of the circle, the point of inclination. Perfect. Now, we know that from our knowledge in circle measurement or measurement of circle, if we divide the entire angle of the circle by the angle subtended by the sector, which in this case is 90, we are going to have the amount of sectors that the circle is going to provide, which in this case is simply 4. So it means this entire circle will provide 4 equal sectors as this. And we can see that each sector will have this object there. So each of them will have object on it, which means the 4 sectors will have object on it. However, one of those sectors, it is the real object that is there. The rest are for the image. So therefore, we can subtract 1 from it and we can have 3. And this formula can be generalized as 360 over theta, the minus 1. And that will provide the amount of image that will be formed by two mirrors inclined at an angle to themselves. So this is something you want to keep in mind in case you are dealing with problems involving inclined mirror. To find the amount of image that will be formed by the two mirrors, divide the angle between them by 360, or divide 360 by that angle, and subtract 1 from it. That will give you the answer. Perfect. Now that we know the formula, we can now consider a situation whereby the mirror are parallel to themselves. What if the mirror are parallel to themselves? How many images will be formed if an object is placed in between them? First, with visual illustration, mirror that are parallel look something like this. And if the object is somewhere around them or in between them, oh, how many objects will be formed? Well, since we have the formula already, that can help us out. So in this case, the answer will simply be equals to n equals 360. Now, when two things are parallel, what will be the angle between them? It should be 0 because they subtend nothing. Okay, the minus 1. Perfect. But unfortunately, we're having division of 0. In general maths, this is often referred to as undefined. But in calculus, instead, we said it's infinity since the numerator is not 0. And since the object is defined, so why will we now say that the image will be undefined? So we have to work with the calculus. So this will be infinity. The result will be infinity because if we plug in value that is approaching 0 in this entire expression, even subtracting 1 from it, we're still going to have a very larger number. So you can practice that. Plug in something like 0.000000001, okay, as at the denominator here. Divide 360 by your result and subtract 1, you're going to have a very large number. So it is tending towards infinity because in this case we consider negative values as well. That is approaching 0. We're going to have negative infinity. So combined, they are infinity. Well, since it is image, we don't really care about the negative part here, just the positive part. But the result in this case will be infinity. Perfect. And that is how it works. Now, here's an exercise for you or a practice problem, depending on how you want it. Find the amount of image that were formed by two mirrors that are inclined at 60 degrees to themselves and 72 degrees. So let me know your solution in the comment section below. And also, if you have any question, feel free to drop it in the comment section below. Thank you. See you in the next video. Bye for now.